Hello all, welcome to Vista's Learning. This is Rakshitha, your chemistry tutor. So still now, I hope you all have known that we have completed our syllabus of chemistry, right? So what am I going to do in today's session? You people might be wondering, no? Yes, today I am going to deal with one short revision. That means I am going to take all the 5 chapters one by one and deal with one shot revisions, as in like all the important questions, like probable questions which might be coming for your exams, or the important definitions, important topics. I will be telling you in a small summarized way, okay, so that it will be helpful for you guys to remember during your exam, and also you can concentrate more on the questions which might be appearing in your board exams, like probable questions, or like few of the questions might be repeating the same in your board exams. So we will start our today's sessions. Okay, so what is the today's session? One short session for the chapter chemical reactions and equations. So what did we learn? What did you learn in this topic? Yes, I have mentioned briefly the topics which we learned in this class or in this chapter, that is chemical reaction. We learned about chemical reaction, the first, and then how to recognize the chemical reaction. How can we identify the chemical reaction? What are the different chemical reaction, different kinds or different steps that happens in the chemical reaction, the changes in their state, the changes in their color, all this we actually learned, and that I have put it under how to recognize our chemical reactions. And the third one, balancing the equation. The most important, the very important concept in chemistry is balancing the equation, right? If we balance the equation itself, we can get to know the chemical reaction is stable or not. Even the chemical reactivity is also found out through balancing the equation. So that is the third part. Followed by types of chemical reaction. What are the different types of chemical reactions we learned? All this is what the next topic, subtopic you learn. And the last one was corrosion. Corrosion and also something called as rancidity, right? I hope you guys remember all these important topics which come under the chapter chemical reactions and equations. Now let's move on with it. Yes, the first thing is chemical reaction. How do you actually define a chemical reaction? How actually a chemical reaction takes place? All this we learned in our classes, right? So I have given a definition there. You can just read through it. A chemical reaction is a chemical change in which the identity of the substance is changed, right? When whatever substance you are taking, the identity of that substance is changed. Suppose if you are taking something in a solid form, that identity can be changed to a liquid form or to a gaseous form, any form, right? It vice versa. Or if you're taking something in a liquid form, can also be changed into a solid form, right? So all this is something called as chemical reaction. So what basically happens in chemical reaction? Yes, I will just highlight it so that it will be easier for you to understand. Yeah, chemical reaction is a chemical change in which the identity of the substance will be changed, right? The identity, whatever the present form, that will be changed. I have just given you one of the picture which is mentioned in your syllabus. You can see, I hope you remember what actually the experiment is. We are taking a magnesium ribbon, we are exposing it to air in the presence of, and we are burning it with Bunsen burner. What is it? What are we getting it? Yes, the formation here. One second. Yes. Yes. The formation, whatever you are getting there, will be a solid form, right? The white color powder. So whatever we are taking the ribbon, that will be in a ribbon form, and it will be in a tape kind of a thing. When you're burning it and when you're exposing it to the air, you can see that it is changing into a solid form, right? That is also one of the change, one kind of a change it's happening. So the identity, it was found in a tape type, its identity is changed into a solid form. So the identity change, the change of the identity, something which happens in the reaction is called as a chemical reaction. And followed by, the reaction, what are we following here? Like magnesium, when it is treated with oxygen, you are going to get a magnesium oxide. And the balanced equation, the balanced equation is what, like 2 Mg plus O2. How you balance the reactions, how you balance the equation, I hope you remember. I will be teaching you, I will be just briefing you about it in today's session. Okay. So for as of now, you can just remember the reaction, the magnesium and oxygen. When it is treated, you will be getting magnesium oxide. So first definition, what you're going to remember in this chapter is chemical reaction. What is chemical reaction and what actually happens? If at all you get a question like, give an example for it, you can give this example. If at all you are okay with this example, there are a lot of other examples which you have learned and also which you see in your textbooks. This is one of the easiest examples which you can give. Moving on, yes, identification of the chemical reaction. What all are the different steps that is identified for a chemical reactions? Yes, you can see change in color, change in state, evolution of gas, and change in temperature. So all these are the identification of a chemical reaction. See, here I am just going to write one by one example for each of the changes. Okay, one by one examples. There are a lot of examples, but I will be giving you one examples for each, so that it will be easier for you people to remember. Okay, so let's move on with the first one, that is change in color. Okay, change in color. The moment you hear that, what comes to your mind? One particular color will be changed to another color, right? It's very simpler if you put it in words, but actually in reaction, what it happens, let's see. Yes, first let's go with yes. So for the change in color, I have taken an example. What is this? The first one is potassium iodide. We are taking potassium iodide and treating it with lead nitrate. Okay. We are taking potassium iodide and treating it with lead nitrate. So when you see this in your lab, when in your laboratory, you can see the color of both these compounds. Both are in white color. So when you mix, when you completely mix this, when you take potassium iodide and lead nitrate and mix it in water, okay, in two separate beakers or two separate conical flasks. After mixing that, mix these two solutions together. So you will be finding one beautiful color. What is that color? Yes, this one. Lead iodide, what you are forming, will be in yellow color. Okay, so you can notice the change in color. There was a chemical reaction that happened, right? Due to that chemical reaction, the potassium iodide and lead nitrate, whatever was taken, was converted into yellow color precipitate. That was our PbI2. Okay, this can be the one of the example for change in color. As I told, there are a lot of other examples too. Okay, next let us go to change in state. Change in state, it's like very simple one. Right now I just explained you about it, right? Like, one second. Yes. One minute. It's just a technical issue here. Yes. Okay, let's continue. So when we are taking this, you can see 2 mg, you are reacting it with oxygen, right? We are taking 2 mg here and we are reacting it with oxygen. We learned this in our before examples, right? What did we learn? Magnesium, when you are taking it to oxygen and treating it, the ribbon, whatever you are taking and treating it with oxygen, we are getting a solid powder, right? That example only we can give it to our state, change in state. So what we are dealing here, 2 mg plus O, right, will be giving you MgO. Okay, so this will be your second example for change in state. Yes, So you learned now change in color and change in state. Now we'll go to the third one, evolution of gas. The moment when you hear evolution of gas, what comes to your mind? Yes, there is something, evolution of gas out of the reaction, whatever is happening. Okay, there is one kind of a reaction which happens when two of the compounds is mixed, where your gases is evolved. Okay, so here we are going to deal with something called as evolution of gas. What exactly happens here? So if you remember your experiments, you can know that you are taking zinc granules in a beaker or in a conical flask. Okay, you are taking the zinc granules and you are adding our king of chemicals, which is that, yes, our H2SO4. So when you are taking zinc and adding H2SO4 into that, there will be evolution of one gas. What is it? Yes, it is our H2. Okay, the reaction will be formed, but also there is an evolution of hydrogen gas out of that entire reaction. So for that, you can give this as one of an example. So let's write the reaction. Okay. Yes, I'm going to write it here. Zn plus H2SO4 gives you ZnSO4 plus H2. Okay, this will be the reaction for your evolution of gas. Okay, now the third one, the last one, the final one is change in temperature. What actually happens change in temperature? Has the name itself tells, there is some kind of change in the temperature that happens. So for this, what example you can give? Okay, I will write it here itself. You are taking CaO and H2O. You will be treating calcium oxide. What it is called as, it's also called as quicklime, right? When you're taking quicklime and you're treating with H2O, what do you get? Yes, you get calcium hydroxide. So this is also one of the example for a change in temperature. So I hope you just, it was refreshed in your mind what and all happened actually. How are we supposed to identify the chemical reaction based on these criteria? So what are those? Change in color, change in state, change evolution of gas, and change in temperature. So these are one of the examples I've given for each of the changes. So you can learn or you can see in your textbook, and there are a lot of other examples also given. So you can pick whichever is easier for you. So let's move on. Yes, the next step is chemical equation. Chemical equation, like whatever we wrote is chemical equation, right? So how are we supposed to write this chemical equation? You can write it in two types, either in word form or in the equation form. So now we will deal with what is chemical equation. Method of representing a chemical reaction, whatever whatever the reaction is happening. Suppose we took magnesium and oxygen treated, we got magnesium oxide, right? All this thing, how are you going to present it? Through some type of a reaction, right? Some type of a method. There is a method for it. That method only is what we learned as chemical equation. So for that definition, what you can take? Yes, method of representing a chemical reaction. Okay, that is called as chemical equation. One example, as I told, that example itself I have mentioned here. You are taking magnesium plus oxygen, which will be giving you magnesium oxide. So in this, what happens? We are seeing magnesium and oxygen are considered as reactants. Okay, the magnesium and oxygen is considered as reactants, and whatever we got from out of that, that is considered as products. Okay, so magnesium and oxygen is called as reactants, and whatever comes out of it, that is called as product. It is also called as word equation, which not this, the same thing when you write it. Okay, magnesium reacts with oxygen will be giving you magnesium oxide. The entire sentence formation is called as word equation. The same word equation, when you convert it into a chemical equation, like an equation with using its symbols, the element symbol, you will be writing it like this. That is Mg plus O2 gives you MgO. So what is the definition? If they ask you the definitions for chemical equation, you are going to give this equation and one of the example. Let's move on. Yes, balancing the chemical equation. Why do you want balancing of the chemical equation? Why is it so necessary? Yes. Why we have to balance? Because to satisfy the conservation of mass. Law of conservation of masses. We have to satisfy that. What is it? You cannot, neither it can be created nor can be destroyed. What? Elements. Whatever we are taking, both of the things should be equal, right? So to balance this, we have to do the balancing of chemical equation. So what can you do? I have taken a very simple example here. Why? Because you guys should remember and you guys should understand it in an easier way. That is why I've always concentrated on Mg, that is magnesium and oxygen itself, so that it will be very easier for you guys to remember. So this is the basic, chemical equation. But the balanced chemical equation goes like this. Okay. So the balanced chemical equation is 2Mg plus O2 and 2MgO. How can you balance this equation? How did you get to balance this equation? Yes. There are 4 steps which you can use to balance the equation. Okay. 4 steps. This is like a trick for you to easily balance the equation in a very short span of time. Let's go it with one by one. Balancing the polyatomic groups. The first step is balancing the polyatomic group. What do you think all these polyatomic groups are? Yes, the groups that are covalently bonded together. Those are called as polyatomic groups. I'll give you a few examples here, okay? See, suppose we are taking OH minus and NO3 minus, then you can take SO4 minus 2. All these are called as polyatomic groups, and also they will be represented always within the brackets. Okay. First, you have to balance those. Balance the polyatomic groups. Next, you are going with balancing the metals. What are the metals? The elements, the periodic table, the periodic classification, whatever we learned, where are the metals present, where are the non-metals present. I hope you guys remember it, right? Yes. First, we need to balance the metal if the metal atoms are present, followed by balance non-metals. Next, you are going to balance your non-metals. Not the entire elements, whatever is present in the periodic table is supposed to be known by you guys. You know what and all are the important elements it is mentioned in your syllabus. Just try to concentrate on that part and learn the balancing of the chemical equation. So as I told, first balance the polyatomic groups, then balance the metals, followed by non-metals, and the last is hydrogen. Okay. First balance hydrogen and later also go on with oxygen. So if you remember these steps, okay, it will be very easier for you guys to balance the equation. Okay. Now, let's balance one equation. Okay, I'll just give you, using the same method, I will teach you how can you easily balance the equation, right? Yeah. This is the equation, this is the example which I am taking. What can you see in this reaction? Is this balance? No, it is actually not balance. Now, we are going to do it step by step by using the trick, whatever I showed you. So, first step was what? We have to know our polyatomic atoms, right? Polyatomic groups. What do you think are the polyatomic groups here? Yes, you can see our NO3. NO3 is our polyatomic groups. Before that, just make a table, okay? So, what the table contains, elements or groups. Next will be your reactants and next will be your products. Okay. So, the first polyatomic whatever element is present here is our NO3. Write down that. Now, how many reactants, how many are present in the reactant sides? How many NO3 atoms are present in our reactant sides? You can count. Yes, you can see 2. And here you can see 1, right? Now, followed by, write the other elements, whatever the other elements are present, either if it is very difficult for you to identify the metals and non-metals right now, you can just write down the remaining elements, okay? Write down the remaining elements first. And K, okay? These are the remaining elements. Now, how many of our lead is present in the reactant side? Again, it's 1. And here, it's 1. I in our reactant side is 1. And when it comes to our product side, it is 2. Followed by potassium, here it's 1. And here also, it is 1. Now, when you see this table, you can easily know which are balanced and which elements are balanced and which is not balanced, right? Which is it? Yes, you can see here, our NO3 is not balanced and our I is not balanced. Okay, now let's add. We can see here, in our reactant side, we are finding 2. Okay, but our product side has only 1. What will happen if we add a 2 here? Okay, 1 second, there's a small error here. This is not there. Yes. So we added a 2 over here. Now, do you think it is balanced? Which is balanced and which is not balanced now? You can find out, right? We are adding a 2 from here. But K became unbalanced. See here, we have K 1 and 1, but here we got 2K and here 1K is there. So what can we do? Yes, we are adding another 2 here. So when you add it, you can just see the entire table will be changed, isn't it? What happens? Now actually what happens when it is changed? I am just going to write here itself. NO3, if you see both the sides, it is balanced, right? PB there is no change. So PB remains the same. When it comes to I, what is happening here? We balanced it. So here 2 also is there in reactant side and 2 also is there in our product side. And K also is changed. 2K and here also it is 2. Okay. This is how easily you can balance our chemical equation. Okay. So the balanced chemical equation, since here it should be remained because I want you guys to copy down. So I'm just telling you the balanced chemical equation is this. 2Ki plus PbNO3 NO3 twice gives you PbI2 plus 2KNO3. Okay. This is your complete balanced equation. This is how you can use it to your n number of chemical reactions to balance it. It will be very easy and simpler for you guys to understand and balance the equation, since balancing the chemical equation is one of the important questions for your boards. And also, as you are going in your higher studies also, whenever you are writing any kind of a reaction, every reaction should be balanced. Okay. I hope this was one of the easier method for you guys to follow it. Let's move on. Yes. Next, we are dealing with the topic of types of chemical reactions. What all the other types of chemical reactions were there? We learned about combination reaction, decomposition reaction, displacement reaction, double displacement reaction, oxidation and reduction. These are the type of the reactions which you learned. Let's deal with one by one definitions, because the definitions are important for your exams. Yes. First, we are going with combination reaction. What comes to your mind when you listen to the word called combination? There is something two things are combining there to give you some result. What is it? Yes. Reaction in which 2 or more reactants react together to give you a single product. 2 products are given, but 2 reactants are taken, but you will be getting a single product. That is something called as combination reaction. Okay. So I have given you 2 examples for that. You are taking very simple examples. Carbon plus oxygen is giving you our carbon dioxide. Same thing, this which we saw in change in temperature. You remember, no, the example? CaO plus H2O will be giving you calcium hydroxide. So what is combination reaction? Reaction in which 2 or more reactants react to give you a single product. That is called as combination reaction. Let's move on. Decomposition reaction. Please note down all these definitions, guys, with the definitions and also 1 or 2 examples, because it is very important in your examination point of view. Okay. Yeah. Decomposition reaction. In this, reaction in which single reactant undergo decomposition to give two or more products. So again, here it is opposite of combination reaction. What happened in our combination reaction? Two reactants, two or more reactants we take and we get a single product. But here we are taking a single reactant itself, but the product will be two or more. So it's easy to remember, no, the combination and decomposition, it's vice versa. Decomposition is opposite of a combination reaction. See, energy, whatever the energy which will be given, it will be supplied in the form of heat, electricity or sunlight. Whatever the energy which will be coming there, that is supplied in the form of heat, sunlight, okay, and electricity. So again, I have taken one example. FeSO4, when you are giving with heat, this is the symbol we represent for heat, okay. FeSO4, when you are giving heat, it gives you Fe2O3 plus SO2 and SO3. See how many products we are getting here? We got two or more products. With just one single, with only ferrous sulfate, we got so many other products. So this is something called as decomposition reaction. Moving on, endothermic and exothermic reactions. So when it comes to physical chemistry, endothermic and exothermic reactions, what actually happens plays a very major role, students, especially in physical chemistry. It's not that it not plays role in organic chemistry, but main concentration or more concentration you can give it in physical chemistry for our endothermic and exothermic reactions. All this you are going to learn in your higher classes. For now, it's only the definitions which you will be concentrating on. So, what is endothermic reaction? The reaction in which heat is supplied. You are giving heat to the one of the reaction to happen. That is called as an endothermic reaction. And the opposite of that, what exothermic reaction? What happens in this? The reaction in which heat is released. The reaction already happens, but there will be the evolution of heat. That is called as an exothermic reaction. Again, it is very easy to remember it together. Endothermic, heat is supplied. Exothermic reaction, heat is released. Right? Yes, the next one was displacement reaction. What is this displacement reaction? Yes, the reaction in which reactive elements displaces less reactive elements. So whatever the less reactive element is used, that is displaced by a higher reactive elements. That is called as displacement reaction. So you can see again here, FeCuSO4, you are using iron and copper sulfate, but it is replaced. Our copper sulfate and iron, when it reacts, it's got replaced. The copper is as formed as a byproduct. Our main product is FeSO4. Why? Why do you think it has happened? Yes, because our iron is more reactive than compared to our copper. So this itself tells you the definition, no students, like we are replacing the less reactive one with a higher reactive one. In this example, you can see it very clearly, a copper is being replaced with iron. Okay. Next, there is something called as reactivity series. The displacement reaction actually is related to our reactivity series. What are those? See, the elements which are arranged in decreasing order of the reactivity. The reactivity order, the reaction which takes place in the particular complete reaction, that will be less. Based on that, our reactivity series is arranged. Let's see how that actually the elements are arranged. In this, one of the example is given. See, AgCuSO4. Okay, we are taking Ag and reacting it with copper sulfate. Again, you are getting AgSO4 plus Cu. Do you think this reaction is happening? No, the reaction will not happen. Why? Because Ag is weaker when compared to copper. So Ag is weaker when it compared to copper. This reaction is not going to happen because whatever we are using our Ag, that is silver, which it will be less reactive compared to our copper. Yes, this is our reactivity series. This is how the elements are actually arranged based on their reactivity series. You can see the most reactive, our potassium, is in the first place. And when it comes to between, as you go down this list, you can see the reactivity decreases. Right? I told you, no, silver is less when it compares to copper because silver is present below copper here. No? So obviously the reaction doesn't happen. It will be less red. In fact, you can see here, It is the least reactive element here, which are silver and gold. So only whatever it is reacting with silver compared to the other elements here, it's very difficult for the reaction to happen. So you can see the series, right? The highest is potassium and the least is gold. Okay, this is how our series are, how it actually goes on our reactivity series. Yes. Following, let's continue with our next type of reaction, that is double displacement reaction. What happens here? Here basically happens is the exchange of ions. The exchange of ions happens, whatever the ions are present in the reactant side, there some kind of exchange happens and we get it in our product side. Okay, that is something called as double displacement reaction. So what is the appropriate definition for that? Yes, the reaction in which exchange of ions takes place is called as a double displacement reaction. So you can see here, we are taking BaCl2, okay? We are taking barium chloride and treating it with sodium sulfate, okay? And what actually happens here, there is exchange. There is the exchange of ions happening in between them. Here you can see, we are getting barium sulfate and NaCl. So what is this barium sulfate? The barium sulfate will be actually in the form of a precipitate. It will be in the form of a white precipitate. So the double displacement reaction is also called as precipitation reaction. Okay. So whatever happens in our double displacement reaction, it is also called as precipitation reaction. Because here you can see in our barium sulfate, you can see there will be a formation of white precipitate when you do a laboratory experiments. That time you can see. So this double displacement reaction is also called as precipitate reactions. Let's move on. The next one was oxidation reaction. So I think by now you are very clear with what happens in oxidation, what happens in reduction, right? Lot of times we have dealt with our carbon and its compounds. In that chapter we have dealt with oxidation and reduction, right? Yes. So what is oxidation reaction? Addition of oxygen or removal of hydrogen. Addition of oxygen or removal of hydrogen is called as a oxidation reaction. For that, I have given you an example, very simple example. We are treating copper with oxygen. You get a Cu plus O2, that's copper and oxygen, you are getting a CuO, right? That will be our oxidation reaction. Very simple example. Let's move on to reduction reaction. So what? It is just an opposite of our oxidation reaction. What happens here? You can see addition of hydrogen or removal of oxygen happens in our reduction reaction. So what is reduction reaction? Addition of hydrogen or removal of oxygen. Again, you have an example of CuO plus H2, you will be getting just a copper and H2O will be a byproduct. Okay. Followed by redox reaction. The reaction in which both our oxidation and reduction takes place. That is called as redox reaction. In this, it's not separately happening. Both our oxidation and the redox reaction will, reduction reaction will be happening simultaneously. That is called as redox reaction. See here, a zinc oxide and you are taking carbon. When you treat, you will be getting just zinc alone and carbon monoxide separately. So which is oxidation and which is reduction here? Which is happening here? You can see our ZNO is getting reduced. Okay, our zinc oxide is getting reduced and our C will be the oxidized one. Okay, so this is again another example for a redox reaction. Now, this is one of the last part of your chapter. What is it? The corrosion and rancidity. What exactly happens in the corrosion? I have just put a picture. I know you all would be seeing this corrosion process in your day-to-day life, right? Corrosion is nothing but when some metals, when it is exposed, when it is actually exposed to some oxygen, vapor, water, whatever it is, all those things, there will be the formation of a brown substance, that will be rusted. That's also called as rusting. And it might be in, like a solid form which is already stuck to the material, or it will be in a powder form. That process is called as corrosion. So what is corrosion? When some metals react with substances like oxygen, vapor, etc., the metals get corroded. Okay, and this is called as corrosion. So this is one of the image for the corrosion, like how exactly it happens, how exactly it looks. This is how the corrosion process happens. For this, I have given one of the example, which is a very common example, that is called rusting of iron. What happens in a rusting of iron? You can see our iron material or iron particle is exposed to oxygen with the presence of water. So you will be getting Fe2O3, right? And iron oxide is formed with an liberation of H2O. This X is denoted like X can be any number, like 2, 3, and so on. So it's better to mention as X. We don't know the exact amount of water, right? So we are giving it as X. So one of the very common example is rusting of iron. The last one is rancidity. This also you see in your day-to-day life, where, for example, when you keep a butter, take a butter and just keep it out of the fridge for 2-3 days, you can actually notice the change in the smell or even the change in the taste. That's where the rancidity process is happening. Not only that, you can take like the image what I have put, the bread image, you just keep it open for a lot of time. You can see the fungus growing on it. Or a chips packet, when you take and you expose it to air, you can see the quality of the chips, how it reduces, right? That all this process happens through our rancidity. So what is rancidity? The reaction of fat and oil with oxygen. All these things contain fats and oils, right? That will be reacting with oxygen. So when it reacts, what happens? We get a foul smell and also the taste changes. So the smell and the taste changes when it is exposed. So that entire process is called as rancidity. So these are the definitions you have to remember. Now, what are your probable questions for the exams? There are very few questions I have put here. Probable, that means might be. Okay, it might be appearing in the exam and you have to concentrate on those kind of questions. Okay, let's deal with it quickly one by one. Yes, the first question. Why should the magnesium ribbon has to be rubbed with sandpaper before the experiment? The whatever experiment I said in the beginning, right, that magnesium treating with oxygen and you're burning it with Bunsen burner, you will be getting a solid form. Before that, you're supposed to rub it. Why? Why do you think? Yes. Magnesium iodide, whatever you use ribbon, has a protective layer. Okay, that protective layer, it's also called as an oxide film. This, what happens, it will not allow the reaction to continue. So, in order to continue the reaction, we are supposed to rub that magnesium ribbon to a sandpaper before using it in our reaction. Okay. So, what is an important key point you're supposed to notice here is our protective layer or an oxide film, which will be present on the magnesium ribbon. When that magnesium ribbon is used, you cannot react it directly because of this presence of this film, and it doesn't allow the reaction to happen. So you need to rub it on the sandpaper before the reaction, before you continue the reaction. Okay, let's move on. Yes, Fe2, I have given one of the reaction. What reaction do you think it is? Like these kind of questions is very important to concentrate, guys, because it will be asked in your MCQs or as a one word questions. Okay, Fe2O3 plus 2Al, you will be getting Al2O3, aluminum oxide. What kind of reaction is this? I have given four options. What do you think it is? I hope you would have got the answer already. Yes, it is our displacement reaction. So the displacement reaction is happening here. Fe2O3 and 2Al, you will be getting an aluminum oxide, right? So the reaction is our displacement reaction, and I hope you remember the definitions of displacement reaction. Why it is called as displacement reaction? You have to go back and look into your definition and for the reactivity series, whatever was mentioned. Okay. Moving on, balance the reaction. Okay, I think this reaction I actually showed you how to balance it. Now, never mind. I have given you the steps. What are the steps to be followed? Polyatomic group. First, you have to balance the metals, balance the non-metals, and finally our oxygen and hydrogen. Okay, these are the steps which you are supposed to follow to balance our reaction. So, what is a balanced reaction? Yes, so this is a balanced reaction. You remember, right? I thought you have to balance this reaction. Now you can see the balanced reaction for that particular question. Moving on. Yes. One more reaction, the same way. Same way, but I have not mentioned the entire process, guys. I hope you are clear by now how to follow the entire process in balancing the equation. This is an actual equation and you need to balance yourself and get to know the answer. Here, I am going to show you the answer anyways. Yes. This will be our balanced reaction for the following reaction. How it happened, how you are balancing? Yes, you are following the method, the same old method, whatever I said, you are following it and you are balancing the equation. So balancing the equation is very, very important to concentrate, students. It will be a very major part in your chapter, in this chapter, that is chemical equation and reactions. And it is a very major question to be asked in your boards. Do concentrate and study about balancing the equation. Yes, moving on. Now, there is also, you can get it in a word form. That also you have to write it in an equation form. So how will you do? I have given you two examples. First one, calcium hydroxide plus carbon dioxide. We are taking calcium hydroxide plus carbon dioxide. And what is the reaction we are getting here? Calcium carbonate plus water. So this is your question. How are you going to write it in equation form? Followed by barium chloride and potassium sulfate. When you treat that, what is it getting? Barium sulfate and potassium chloride. So how exactly the equation is written? Yes, this is how we are going to write the equation. So calcium hydroxide and a carbon dioxide is treated and you are getting a calcium carbonate with the water as a byproduct. And also barium chloride, BaCl2 with potassium sulfate. You will be getting barium sulfate plus KCl. Okay, that is nothing but potassium chloride. So whenever you are getting this in the written word form, you have to write it like this with the balancing. Okay. Moving on, what is exothermic and endothermic reaction? So for exothermic and endothermic, I told you how you are supposed to remember. What is our endothermic reaction? Yeah, the reaction in which energy is absorbed. Okay. And exothermic is energy is released, heat is released. With an example, you can see, I have given one example for each. In exothermic, we are taking methane and treating with oxygen. We will be getting carbon dioxide and water as a products. Okay. And for endothermic, we are taking carbon dioxide and water, treating it, and we are getting C6H12O6 and also our H2. So whenever the question is asked, it's very compulsory. It is very necessary for you people to mention the examples for each of the definitions, because when you give the examples for each definition, that gives a weightage for your answer. Okay, you cannot just write like what is exothermic reaction, just write the definition and leave it. No, you have to write one examples for each. Not only this, any kind of whatever definitions we learn through, for everything, make sure you learn one examples so that your answer will be having more weightage and you can score marks very easily. Okay. Next, oils and fats containing food items are flushed with nitrogen. Why? Why do you think it will be flushed with nitrogen? Yes, the main actual answer in this, whatever we are being exposing it, it will be undergoing rancidity, right? That we learned here. Whatever is exposed to an oxygen, or we will be getting a foul smell, or the taste of it will change. For that, what we do, nitrogen will be providing an inert atmosphere. Okay, it will be giving an inert atmosphere for all these items. That time, it will be very easy for fats and oil to be flushed. Okay, this will be your answer. So what exactly, how can you put it in words? See, in order to avoid the oxidation which results in rancidity of products, due to this, the taste of the food changes and also the smell changes. So what is the role of nitrogen? Here, nitrogen also provides an inert atmosphere. This is an important word. This, inert atmosphere. Nitrogen gives an inert atmosphere for the food. Therefore, oil and fats containing food items are flushed with the nitrogen. So what? Nitrogen will be providing an inert atmosphere. That is the reason why it is used as flush. For us, oily and fats containing food. Okay. Moving on. What is quicklime? Mention any one use of it. Yes, our calcium oxide, which is called as quicklime. A calcium oxide is called as quicklime, which is a CaO, which is represented as CaO. What are its uses? Yes, you know, it is used in the manufacture of cement. The main use is manufacture of cement. Also making porcelain and glasses. Okay, any of the example, if it's asked for one, you can mention any one example. So what is the quicklime? Our calcium oxide is called as a quicklime. It is also mentioned as CaO. So one uses manufacture of cement or making porcelain and glasses. Moving on, yes, in the refining of silver, the recovery of silver from silver nitrate solution involves displacement by copper metal. Okay, concentrate on all these keywords. Silver from silver nitrate solution involves displacement by copper metal. Okay, these are the keywords in this question. What is the reaction involved? So once you notice all the keywords, that's how you can easily identify what is the reaction, what will be the further reaction. What are the further reactions? Yes, we are taking silver nitrate and reacting with copper, right? That's what is the thing. Silver, we are taking recovery from silver to silver nitrate. So this will be our reactant. This will be undergoing the reaction with copper. Silver and copper is what is going to, silver nitrate and copper is what is going to undergo the reaction. What kind of reaction? Yes, it is mentioned displacement reaction. So when this happens, what is the reaction? What is the product? We are getting copper nitrate with the liberation of silver, right? So this is the reaction for our displacement reaction. See, such type of mentioning in the words, this kind of questions can also be appearing, students. You have to remember very carefully. You have to note down the important keywords which is given here. That time it will be easier for you to know what kind of reaction is happening. Or this question might appear in another way also. They might just give you the entire reaction and they might ask what kind of reaction is happening here and explain it. So that time you have to write what kind of reaction and the definition for it. Okay, the question can come in any kind of question terms. You have to learn it in such a way that anyhow the question is asked, you should be able to answer. Moving on, what happens when hydrochloric acid is added to iron fillings? When our hydrochloric acid, that is HCl, is added to iron fillings, what happens? I have given the options. Hydrogen gas and iron chloride are produced, chlorine gas and iron hydroxide are produced, no reaction takes place, and the following one is iron salt and water are produced. So first you have to know the reaction, what actually the reaction is. Then only you can understand what basically happens here. Let's see. The option is hydrogen gas and iron chloride are produced here. So the option A is the right answer. What is the reaction? Yes, when you're treating our iron fillings, you're taking iron, Fe, and you're treating it with HCl. What do we get? FeCl2 plus H2I. So what are we getting here? FeCl2 plus H2I. Ferric chloride and a hydrogen iodide. Okay. So what is an option? Hydrogen gas and iron chloride are produced here. Yes. So in today's class, you learn what all are the important concepts, like what important concepts will be in our first chapter, that is our chemical reaction and equation. And also what and all would be the probable questions that might be appearing in your exams. So whatever I dealt, all these questions or all these definitions, whatever I dealt with, I hope you are clear with it. Please do learn all these important definitions, students, because this covers the major part of our topic. So once you are very clear with this, all these definitions, and with the definitions, with all these examples, whatever I gave, it would be very easier for you to understand this chapter. And also when it comes to the probable questions for exams, do note down, this might, as I told, this might be the type of questions which might be coming in your exam, or this kind of questions exactly may also appear in your final exams. Okay, so do concentrate on all this, all the definitions what I gave, and also these kind of questions which is going to appear. Okay, so until this is Vista Learning, quality education for all. I hope you like the class, and if you like